although it is a bit of a stress-strain question actually.
Double wire plane, 2.6
Right, so it's actually a materials question. So, what is the stress? So what's the formula for stress? Force over area, which is force over pi r squared, and the radius is given as 0.4 of a millimeter. The only thing is we have to find the force, which is a little bit of work. Let's first find the force, okay? I'll just do that by going to the side. Are you looking? So there's one force going down. How much is that? 3G. And there's two forces which we care about, the T and the S here. Now, in fact, I know that these forces are the same because the image is perfectly symmetric. Everything is the same on the left and the right. It's a mirror image. So they have to be the same. Okay? Now, let's imagine that we worked out this angle here, which we could easily work out. We call it theta. Okay? What would this side be? This would be T cos. Oh my goodness.
Cos theta.
Oh, hang on, something's gone terribly wrong. The heck? DEFCON 2. How did I get rid of this? I don't even know what I pressed. What the heck did I just...
That's in the pen. Yep.
Can I still write? No, I can't. Okay.
Yeah.
No, I need to get the pen back. Right. But I'm in some weird non-pen mode. What mode am I in? I don't want this picture mode. How do I... The paint. Go. Now, this is... So you watch Flash then? Or Arrow, I mean. Yeah. T cos theta for this one here. But what about on this side? Well, there's also a
Sine.
T cos theta from this side. So in total there's 2 T cos theta. And what should that equal? 3G. So we could say that T equals 3G over 2 cos theta. Now if you look at the picture, you can work out what the theta is. Can you see the picture here? It'll be, yeah, so I'll work out the theta. It's sine inverse 0.7 over 0.8. So in fact the theta is 61 degrees about. So if I do 2 times cos of the theta, and then it's 3G divided by that. I got my T is 30.4 Newton. So with that I can now go back to the right.
Where do you get theta?
Sine inverse 0.7 over 0.8.
Oh, it's like that.
Yeah, going back?
Yep.
Right, so now that I have my T, I now know what my F is. Now, remember we're just looking at one wire. It says the stress in the wire, and there's only...
You already get the stress.
Yeah, and let's type it in. So, what's my F? What did I say it was previously? 30.4. And my radius is 0.4 of a millimeter. The tension. in the row, yeah. So stress is usually a big number, and my stress, I believe, is right. It looks good. It is correct. So if you put in the numbers here, now will I do it in megas, or will I do it in gigas? I'll do it in megas. 60.5 megapascals. Okay, and the next part is what's the strain. Now, what formula should we use to get the strain?
Young modulus equals.
Yes, very good. Young's modulus equals stress over strain. So really it's just the strain is the stress divided by Young's modulus. Right?
Yeah.
So what is Young's modulus in the question?
1.17.
So that is 5.17 times 10 to the minus 5, which is
Correct.
incorrect. He has a minus 4 and I have a minus 5, which means maybe I must have mistyped something previously. Can you tell me what my stress was again?
1.17 times 10 to the power 11.
No, my stress.
stress.
What is it?
60.5
Times
megapascal.
mega is 6
Yeah.
divided by
1.17.
what's that? No, what? Like everyone else? Yeah. Maybe I should have. Oh well. That's what I get. I think 5. Yeah, that's right. Yeah. So here we get 5.17. I just typed it wrong. Minus 4. Okay, and then the last part is the extension. So what formula do we use for extension?
Minus kx.
That the strain is the extension over the length. So what's the extension then? It's the length multiplied by
Strain.
the strain, which we have on our calculator. So what's the length of the wire?
1.6.
Yeah, we have to be careful now. What's the length of the wire though?
1.6.
No.
One point.
What do we use as the length? Who can tell me?
1.14.
What?
The diameter. No.
1.6.
You think so?
Yeah.
Oh, okay. I would have felt like maybe 0.8, but
Why 0.8?
because we're only looking at half of it. But I guess he wants the total extension, so if on each side it would be, yeah, okay, so
You said
1.6.
wire. Not the half.
Yeah, okay, 1.6. So we get an answer of 0.827 millimeters, which is correct.
Question 8.
8 now. Can I close this one? Yeah.